Hi, so in this video we're going to look at linear inequalities and absolute value. So in the last video we covered a lot of examples of solving linear equations. In an equation you're looking for one value that will satisfy that equation. With linear inequalities we're dealing with less than, equal to, less than, greater than or equal to, and greater than. And we want to determine an entire set of solutions. So in this first example, we have 2x plus 4 is greater than or equal to 6. So basically we're looking for all of the values of x that would make this a true statement. So what values of x can we plug in to make this expression greater than or equal to 6? So it could be equal to 6. So we're going to solve this the exact same way that we solve an equation by isolating that variable. So we're going to subtract 4 from both sides first, and that leaves us with 2x is greater than or equal to 2. And then the next step is to get rid of that 2 here. That's 2 times x, so the opposite of multiplication, or the inverse of multiplication, is division. So divide by 2 on both sides, and we get x is greater than or equal to 1. And that's it. That's our answer. So any value of x that is equal to 1 or bigger than 1 will satisfy this inequality. So that's all that we need to do to solve for those. So I'm going to show you one other type of example. There's one thing to consider with these, and that is if you divide or multiply by a negative when trying to solve and isolate a variable. If you are multiplying or dividing by a negative, you will need to flip the inequality sign. So an example of that would be 2x minus 5 is less than 2 times 3x plus 3. Now I've given another one that we need to simplify. So like I said, just like the equations, we treat this where we need to simplify both sides first. I see that I have a 2 out here that I need to distribute, so I'm going to do that first. 2x minus 5 is less than 2 times 3x, 6x, 2 times 3 is 6. And now I have a situation where I have a variable on both sides, so just like the equations, I'm going to work to get those on one side. I'm going to subtract the 6x. Notice some of you may be thinking, well, could I have subtracted the 2x? Yes, you can have the variable on this side or that side, it doesn't matter. I generally like to have it on the left side, especially with linear inequalities, because it's just easier. Our brains kind of have been trained, I think, to recognize it that way, but it doesn't actually matter. All right, so 2x minus 6x gives us negative 4x. Bring down the minus 5, bring down the less than sign. Those cancel and bring down the 6. Continuing to solve, I'm going to add 5 to both sides, and then those will cancel. I'm going to have negative 4x is less than 11. Okay, my next step, I need to divide by negative 4x, or I'm sorry, divide by negative 4. So I'm going to do that, but here's the part that I was mentioning at the beginning. This is the special type that we need to pay attention to. If you have to divide or multiply by a negative at any point in the problem, then you will need to flip the sign. So what happens in this next step is that this becomes x is greater than, and I'm just going to leave this as an improper fraction, negative 11 fourths. You certainly could change that to a decimal. Again, look at Alex to determine, it might give you specific instructions as far as that goes. But the key here is that if you divide or multiply by a negative, then you need to flip that sign. Now, if there's a negative in the problem, that's fine. You don't necessarily need to flip. It's only when you're dividing or multiplying by that negative that you would need to flip. So for example, if you have x over 3 is greater than negative 4, there's a negative in the problem, but to solve that, you don't have to deal with that negative. You have to get rid of this 3, and this is x divided by 3. The inverse of division would be multiplication. So we're going to multiply by 3, do that over here. I'm multiplying by a positive, so this sign will not flip. Those cancel. I have x is greater than negative 12. One other note on this is when you're graphing on a number line, If it's less than or equal to or greater than or equal to, it's inclusive of that number, means it could be equal to that number. So we represent a solid dot on a number line. With this one, a greater than, or if it was just a less than, it's not inclusive, and we use an open circle to denote that it's not inclusive of that number. If it's greater than, if the variable is greater than, we shade to the right. That means x could be anything bigger than that negative 12. Otherwise, we go to the left. Okay, so that's a quick little review of inequalities. So the other thing I'm going to address in this video is absolute value. This is a little bit trickier, but I think if you can kind of wrap your head around what absolute value means technically, then it's not that bad. So absolute value is simply the distance from 0. So if you can kind of hold on to that value, or that kind of idea of what absolute value is, I think that's very helpful here. If the absolute value of x is 3, that means that the distance of x from 0 is 3. So if you think about where 0 is on a number line, you could go 3 to the right or you could go 3 to the left. So that means x could either be 3 or it could be negative 3. So there are two solutions to that equation. When you consider this, then, so if you take this absolute value, again, is the different distance from 0. So the absolute value of 3, distance of 3 from 0 is 3, distance of negative 3 from 0 is 3. So we have two solutions to that. Now these could be a little bit more involved, like x plus absolute value of x plus 4 equals 5, where you have more going on here, but this just means that, the distance of this entire expression from 0 is equal to 5. So it could be equal to negative 5 or 5 itself. So x plus 4 equals 5, or x plus 4 equals negative 5, because again, it's the distance from 0. So then I just want to solve both of these. Notice a key thing here is that I'm using the word or. That means that it's one or the other. Both of them would work. So we are considering more than one solution on these. All right, so to solve this, just quickly subtract 4 on both sides. We have x equals 1, and then over here, solve this one, we get x equals negative 9. So again, I mentioned in the previous video that when you solve, your solutions should satisfy your equation. So I encourage you to always go back and plug these in and see if they work. So if we take 1 plus 4 is 5, the absolute value of 5 is indeed 5. If we take negative 9 plus 4 is negative 5, the absolute value of negative 5, again meaning the distance from 0, is equal to 5. So that checks out. So that is solving absolute value problems. There are problems that get a little bit more involved where you have to do a little bit more solving. So for example, you might have 2 times the absolute value of x minus 3 equals 4, and in this case you just want to isolate the absolute value. Notice that these things are not, the 2 and the negative 3 are not part of the absolute value, so we want to get the absolute value by itself before we start to look at that distance from 0 and consider the two solutions there. So on this one we would add the 3 first and get 2 times the absolute value of x equals 7, and then continuing to solve, we divide by 2 on both sides, because again that's 2 times that absolute value of x, and we would end up with absolute value of x equals 7 halves, or 3.5. And then this just again means the value of x is 7 halves away from 0. So that could be 7 halves or negative 7 halves. And we can just look at that and tell what that is without setting up two separate equations, since it was just the x and the absolute value. So there are some that you will have to simplify a bit first before you consider the distance from 0 and consider what the two solutions are. But always absolute value means the distance from 0, and that's what you're considering, so you just set it up as an OR problem. One thing to note, absolute value has to be positive. So just a side note here, if you have something like absolute value of x is equal to -2, that is not possible. You cannot have an absolute value that's equal to a negative number, because by definition, absolute value is the distance from 0, and distance is a positive value. So this would have no solution if you ended up with something like that. All right, that's it for this lesson.